Chapter 1, Section 5, problem number 6. So we have this equation where F, the Y value, is in degrees Fahrenheit, and T is time measured in minutes. So that's in minutes. And this is a cup of coffee sitting out. And so as time passes, it should be cooling. Now, at time 0, if I put 0 into this equation, this would be e to the 0, which is 1 times this. We'd get 75 plus 110. It's set out at 185 degrees Fahrenheit when it's set out. And then as time passes, it's going to drop fairly quickly and then less when the temperature of the room is less different than the cup of coffee. So it's going to look something like this. And now we're supposed to use the central difference with h.01 to find how much the temperature is changing after 10 minutes. So to find out here at 10 minutes, we're trying to find the slope. And to do that, we're not going to find the temperature at 10 minutes. We're going to do it by the central difference theorem. We're going to look 0.01 before that. So we're going to figure it out at 9.99 minutes. And we're going to figure it out at 1/100th of a minute past 10. So we're going to figure out the temperature at 10.01 minutes. So we're finding 2 points on either side of that, and we're going to find the slope of that. So now I'm going to pull out my calculator. Where did I put it? Here. And type this equation in. So I'm going to do it on calculator instead of Desmos because it's harder to show my screen. So I'm going to go to my equation and type in this equation, 75 plus 110 e to the negative 0.05x. Okay, so there's my equation. I get some reflection. There it is. Okay, and I've got my table set on auto ask, so I can go to my table and delete all the stuff I have in there, and I can ask what is going to be the temperature at 9.99 minutes. And it says the temperature is at 9.99, the temperature is 141.75 degrees Fahrenheit. Now I'm going to go to 10.01, which is a little bit past it. And at 10.01, I get a temperature of 141.69, which makes sense. It dropped a little bit in temperature from 141.75 to 0.69 over this 0.01 and another 0.01 over 0.02 or 2/100ths of a minute. So I want to find the slope so I know how fast it's changing at 10. This is going to be an estimate. So I'm going to take y2, this from that, or look at it, and went from 75 to 69. That's 0.06 degrees Fahrenheit lower in temperature over, so it's down that much, over the time that changed was 0.01 twice, or 0.02 minutes. So if I divide that into there, I get it's falling at 0.02 into 0.06 is 3 degrees Fahrenheit per 1 minute. That's my estimate for how fast the change in the temperature is changing after 10 minutes. If I wait another minute, it should be another 3 degrees lower, or whatever it is. Well, it's about 141, so it should be down to 138-ish. Okay? All right. What are the units of this? So I got that, degrees Fahrenheit per minute. What is the practical meaning of this? So I've already explained it. It means that at around 10 minutes, it's losing 3 degrees Fahrenheit per minute. Which do we expect greater, the change in temperature at 10 or at 20? At 20, because this is curved like this, the change is going to be less negative, so it'll be more positive, so it'll be greater there. Remember, that's a negative slope, and it's a bigger number, but smaller because it's in the negative. When I go to here, it's going to be like negative 2 degrees Fahrenheit, which is bigger than negative 3 degrees Fahrenheit per minute. Write a sentence that describes the behavior of this on the interval from 0 to 30. How do you think the graph would look and why? So on that interval, the temperature is going to drop quickly at the beginning and then slow down, because how fast the temperature changes in my cup of coffee will depend on how much different the temperature of the cup of coffee is than the room temperature. If I put a cup of coffee out in a really cold day, it's going to drop faster at the beginning and then go even colder than it does on a hot sunny day. Then the temperature won't drop as fast, and it won't go down as slow. So that's kind of what they wanted you to understand there. Okay, number 7. Okay, so the temperature in a patient, so this is the patient's temperature. It's scary that it's going to be changing, but if they give them Q amount of milliliters, some quantity of some drug, is given by some statement. And so this is saying when they give them, this is T is F, so this is the temperature, and this is the milliliters of drug. So if they give the patient 50 milliliters, this is the temperature change. This is how much the temperature changes, not the temperature, but the change in temperature. So if they give them 50 milliliters, the change in temperature will be 0.75 degrees Fahrenheit. So I just explained what this means. If a dose of 50 milliliters are given, the change in the temperature will be 0.75 degrees Fahrenheit. A person's sensitivity to the drug is defined as the rate of change in the temperature. So what are the units of the sensitivity? So here we give milliliters, so this is still the milliliters, but the sensitivity is the change in the temperature per the change in milliliters of drug. So that's considered sensitivity. So giving them 50 milliliters causes the temperature to change 3/4 of a degree, and it looks like positive, so it's going up 3/4 of a degree. Now the sensitivity is how much does the temperature change per milliliter that we give them. Now some people, if you give them a few milliliters, and it might cause the temperature to rise a lot, and some people You give them some milliliters, and the raise in the temperature might not be as much. So here it's saying when you're giving a dose of 50, the rate of change per milliliter is 0.02 degrees Fahrenheit per milliliter. So in other words, if they were to go to 51 milliliters, the temperature would drop 0.02 degrees Fahrenheit from whatever they were at 50. So the rate of change in this, instead of 75, it would go to 73.73. So it means a change in the little bit more medicine is going to decrease how much temperature that goes up. That's what this one's all about. A little bit confusing.